Algebra is a very significant portion of the SAT. Now, you might see the word algebra and get goosebumps. You think back to Algebra 1 or Algebra 2 and you worry, like, how could I possibly remember all of those rules? There are so many rules. Well, here's the good news. The actual range of algebra topics that come up on the SAT is pretty limited. And I would argue that they can all be boiled down to one fundamental rule. That's what I want to talk about first here. And that is the rule of the balance beam. So let me explain what I'm talking about here. We all know what a balance beam is, right? It's to measure the weight of two items against each other. An equation is like a balance beam. It says whatever's on this side weighs as much is equal to whatever's on that side. And the fundamental rule of algebra, the balance beam rule, as I call it, is that if you do the same thing to both sides of a balance beam, you're okay, right? So I could add 10 to both sides of a balance beam. I wouldn't have changed anything. I could divide both sides by 41 and I wouldn't have changed anything. I could add a rubber band, a pencil, and some loose change to one side, and as long as I do the same thing to the other side, I'm okay. So let's see how this actually looks in practice. I'm going to start us off with a very simple looking equation, right? 2x minus 6 equals 28. Now, as a reminder, we use x as a variable, right? It stands in for what goes there. It's an unknown. So if my goal, and I know we're going very much back to basics here, but it's good to review the fundamentals. My goal is to get x by itself. At the end of the day, what I want is something that says x equals everything else on that side, right? What's stopping that from happening? I'll draw my balance beam here. Well, what's stopping that from happening is the fact that I have a 2 in front of the x and then I subtract 6. So how could I undo what is being done to the x, right? Let's start with this minus 6. How do I undo a subtraction? Well, I add, right? Adding to both sides negates or cancels out a subtraction. So let me add 6 to both sides and watch what happens when I do that, right? The 6 cancels out, right? And I add 6 over there. So what I get is 2x plus 0, because that has canceled out, equals 34. Now, some of you might say, well, why did you start by subtracting 6? Why didn't you start by dividing by 2? I could have. The issue with that, though, is that if I divide by 2, I have to divide the whole side by 2, right? And then I'm getting into order of operations and parentheses. But if I just add 6 to this side, I'll just rewrite this as 2x minus 6. I'm adding 6 to that side. I'm not changing anything. That cancels out and I don't have to worry about it. So what I'm left with over here is 2 times x equals 34. Well, 2 times x equals 34, multiplication. How do I undo a multiplication? A division, right? I'm going to divide both sides by 2, like that. Boom, boom. And what I get is x equals 34 divided by 2, which is 17. Now, let me just say, if this was at all a struggle for you, and it's fine to review it, but if this is at all a struggle for you, I would take a look back at the most fundamental questions of algebra. It's good to retrain yourself. If it came very easy, then let's move on. All right, let's do a couple questions to refamiliarize ourselves with the basic dance moves of algebra. Pause the video and give this a shot. If 3x plus 6 divided by 4 equals 3, what's the value of x? All right, well, let me set up my balance beam here, as I like to do. And I'm going to start by saying that 3x plus 6 over 4 is the same thing as 3x plus 6 divided by 4 equals 3. So I have this entity, this unit, divided by 4 equals 3. My goal, as always, is to isolate x. So how am I going to do that? Well, let's undo what is being done. How do I undo a division? I undo a division with a multiplication. So multiply both sides by 4. Multiply that by 4, and multiply that by 4. So the 4 goes away, the division is undone, and I get 3x plus 6 equals 12. Okay, well, now I'm back where I was in the other question. Let me undo this addition with a subtraction. So that goes away, and I'm left with 3x equals 6. And now I'm going to divide both sides by 3. There we go, chop, chop, and I get that x equals 2. So the correct answer is B. Now, I'm peeking ahead a little bit, but there's another way to solve this question. If you completely, drew a blank on how to do algebra, you can just plug these back in for x. But more on that later. All right, one that's a little bit harder. And here we're going to talk about distributing, right? I'm assuming that you're pretty familiar with these terms based on, 7th to 8th grade math. But again, if you need a review, you might want to go back and review some of that. Okay, so balance beam, always. 4x minus 2 equals 7 times 5x minus 3. Remember how we distribute into a parentheses, right? We multiply each term separately by the term in front. So what I get is 4x minus 2 equals 35x minus 21. Okay, now this is interesting because I have two x terms, right? What do I do with that? Well, in this case, I want to combine like terms. Maybe this is ringing some bells, right? In other words, I want to get all the x's on one side and all the non-x's on the other. So let me start with the x's. I'm going to get all the x's on the left side. So how do I undo this, or how do I get it off of this side? Well, I subtract 35x from both sides. Now, 4x minus 35x is what, right? It's negative 31x, right? 4 minus 35 is negative 31. And then I'm going to add 2 to both sides here so that 2 goes away, and that's gone away now. Negative 21 plus 2 is going to be negative 19. Now, if you struggle with positive and negatives and addings and subtractings like that, one way to kind of get your head in the right place is to draw a number line, right? So for instance, when I was at negative 21 and I wanted to add 2, how would I do that? Well, I would start at negative 21 and I would add 2, and there I am at negative 19. Just a little trick to help you keep it straight. Okay, so I'm almost done here. I'm going to divide both sides by negative 31. Divide both sides by negative 31, and what do I get? Well, I get x equals negative 19 over negative 31. The negatives cancel out, right? Because a negative divided by negative is a positive, and so I get 19 over 31, which is answer option A.